Hello everyone. In this video, we are going to discuss about Chemical Engineering GATE 2022 Process Instrumentation Dynamics and Control Questions with Solution. GATE 2022 question paper and answer key link is available in my description box. You can download it. Question number 58. In the block diagram shown in the figure, the transfer function g is equal to k by tau s plus 1. With k greater than 0 and tau greater than 0, the maximum value of k below which the system remains stable is dash. After calculating the k or gain value, we have to round off the result to 2 decimal places. So here block diagram is given. In this given diagram, we take some variables like A, B, C, D, E, F. So first reduce the block diagram. So to reduce the block diagram to determine the transfer function y by u. So how to reduce the block diagram we will discuss now. So here first reduce the G block diagram. So in this diagram, so generally apply the transfer function definition. Transfer function is define the ratio between output deviation variable to input deviation variable. So here input deviation variable A, output deviation variable is a B. So G is equal to B by A. So if next we are going to take the second box or block, that is G. Here apply the same definition. So the transfer function is equal to output deviation variable C, input deviation variable B. Okay. So here G is equal to C by B. So these twos are over. So multiply these two box or block. So here G into G, G squared. So here first G is equal to B by A. The second one C by B. So B's are cancelled here. So finally G squared is equal to C by A. So from these C is equal to A into G square. This is the first expression. So next we are going to apply the concept in summer. So this is summer expression. So here C plus D is equal to A. So this is the expression for summer. So here the C is also entering, D is also entering. So adding these two, that is equal to A. C plus D is equal to A. This is equation number 2. So now we have the C value. So refer the expression 1. Substitute equation 1 in equation 2. Equation 1 A G squared plus D is equal to A. So the substitute here. Finally we get A G squared plus D is equal to A. So from this expression we are going to find out the A value. So the rearrange this expression here. So D is equal to A. This values are comes to this side minus A G square. So common term A take outside, A into 1 minus G square. So from this A is equal to D by 1 minus G square. This is equation number 3. So then next we are going to concentrate the this block. So this block, so what is the input variation variable or output variable? So the input deviation variable is A, output deviation variable is E. So generally transfer function output deviation variable to input deviation variable. So here G is equal to output deviation variable E divided by input deviation variable A. Are you clear? Okay. So here G is equal to E by A. So from this what is the E? A into G. This is equation number 4. So next we are going to concentrate this block. So here, so G, apply the same definition. So G is equal to output deviation variable F, input deviation variable U. So here F by U. So G is equal to here F by U. So from this F is equal to G into U. Again we have summer is right, summer symbol. So here E is entering, F is entering, E plus F is equal to Y. So this is the next function, E plus F is equal to Y. Now we have E value and F value. So refer the equation 4 and 5. Substitute here. What is the E here? AG. F is a GU. So the substitute equation 4 and 5 in sixth expression. Sixth expression is a summer expression. Substitute here. AG plus GU is equal to Y. This is the seventh expression. This is a summer expression. This is the seventh expression. So now we have A value is right. So already derived value A. Refer the equation 3 here. So we have A value. A is equal to D by 1 minus G square. Seventh expression also having the A. Substitute here. So the seventh expression AG plus GU is equal to Y. Substitute equation 3 in 7. So here D by 1 minus G squared into G plus GU is equal to Y. This is the 8th expression. So next we are going to concentrate the another block, that is G here. So apply the same definition here. So what is the transfer function? Output deviation variable to input deviation variable. Output deviation variable here D, input deviation variable Y is right. So generally G is equal to output deviation variable D, input deviation variable Y. So G is equal to D by Y. So apply the concept. So G is equal to D by Y. From this D is equal to Y into G. This is the 9th expression. So here we have D values, right? This is the 9th expression. So this value substitute in 8th expression. So here 8th expression having D is right. So the replace the D. Substitute 9 in 8. So YG divided by 1 minus G squared into G plus GU is equal to Y. So from this expression we are going to find out Y by U, that is a transfer function. So here G is outside, Y G squared divided by 1 minus G squared plus GU is equal to Y. So here from this GU is equal to this value goes to this side, minus value. So Y minus, there is a cross multiply is right, Y minus Y into 1 minus G squared is right, Y minus Y G squared. Here 1 minus is there, minus YG squared whole divided by 1 minus G squared. So here this is GU into cross multiply 1 minus G squared, that is equal to Y, take outside common term, 1 minus G squared minus G squared. So here minus G squared minus 2G squared. So G into 1 minus G squared divided by 1 minus 2G squared is equal to Y by U. This is our transfer function. So Y by U is equal to G into 1 minus G squared divided by 1 minus 2G squared. This is the 10th expression. So now what is characteristic equation? Generally characteristic equation Y by U is equal to G of S divided by 1 plus G of S. So here this is G of S divided by 1 plus G of S. So from this expression, what is the characteristic equation? 1 plus G of S is equal to 0. You compare this expression. So this one and 10th one. So here 1 G of S divided by 1 plus G of S. So the characteristic equation 1 plus G of S is equal to 0. You compare. This is a general form. So here 1 plus G of S is equal to 1 minus 2G square. So take the characteristic equation from our equation. 1 minus 2G squared is equal to 0. Are you clear? Okay. So this data already given. Refer the question. G is equal to K by tau s plus 1. So here substitute the G value. So 1 minus 2 into G squared is right. K squared divided by tau s plus 1 whole square. So equal to 0. towers plus 1 whole squared minus 2k squared whole divided by towers plus 1 whole squared. Now this is cross multiply, mean that values are equal to 0. So don't worry about the denominator term. So consider only the numerator. So rearrange this expression. Finally we get tau squared s squared plus 2 tau s plus 1 minus 2k squared equal to 0. Okay. So this is our equation, characteristic equation. So by using Routh array test. So by using the Routh array test to determine the proportion sensitivity or gain value. So Routh array test some procedure to determine the k value. So what is the procedure? First introduce the numbers q, q1 and q2. This is the coefficients is right, q1 and q2. So here number of, first identify the number of roots or find out the number of roots in Routh array test. Number of roots that is m is equal to 2. Why? Because this is s squared na. So that's why number of roots is equal to m is equal to 2. So next find out the number of rows. Number of rows mean m plus 1. M is 2 plus 1, that is equal to 3. Are you clear? Okay. So now we have number of roots and number of rows. So here already we have some coefficients, known coefficients. Q1, Q2 is equal to known coefficients value. So here how to construct the Routh array? Here we have 3 rows is right, R1, R2 and R3. So which one is the roots here? That is 2 is right. So this is the mth row. So why? Because number of roots assigned the variable m. So this is the mth row. Previous row is a m minus 1th row. Next row is a m plus 1th row. That's why R1, R2 and R3. So here some procedures we should follow to construct the Routh array. So here Q, this is Q2, Q4, Q6. Okay, this is this row, first row. Second row only odd number, Q1, Q3, Q5, Q7 like this. Okay, next these are the unknown coefficients. A1, A2s are unknown coefficients. So introduce the unknown coefficient A1, A2. Okay, so here tau squared s squared plus 2 tau s plus 1 minus 2 k squared equal to 0. This is our characteristic equation. Already we have. So from these, which one is a q? S squared coefficient, that is tau squared. Then q2 1 minus 2k squared. Then next row, second row only odd numbers, q1, q3 like this. So that coefficients. So here our equation we have only q1, q3 we don't have. Simply we should take 0. So here q1 2 tau, q3 0. So known coefficient a1 and a2. Are you clear? Sorry, unknown coefficient, that is a1 and a2. So how to calculate the unknown coefficients value? Q, q2, q1, q3 these are the known coefficient. A1, A2 is the unknown coefficient. So here how to calculate the unknown coefficients here? Unknown coefficients can be calculated by cross multiplication method. So here the next column is not available. That's why we should take simply A2 values are 0. So here we are going to calculate only A1 by cross multiplication method. Cross multiplication mean here A1 is equal to here Q1 into Q2 is right, Q1 into Q2 minus Q into Q3. So here Q into Q3 divided by Q1. Okay, so this is the A1 formula. So now Q is Q1 is 2 tau, Q2 is 1 minus 2k squared minus Q3 tau 2 into 0, that is 0, divided by Q1, that is 2 tau. So here the 2 taus are cancelled. Finally we get A1 is equal to 1 minus 2k squared. So again construct the Routh array. So here we have now A1 and A2 value. Substitute here. So 1 minus 2k squared, then 0. So Rauteri test having some procedure to identify the system is stable or unstable. Here how to identify the system is stable, the question itself they have mentioned tau greater than 0 and k greater than 0. See the Rauteri here. Any coefficient of the first column is non-zero or positive, the control system is stable. Okay, so here 1 minus 2k squared greater than or equal to 0. So r equal to 0. 1 minus 2k squared equal to 0. From this find out the k value. 1 minus 2k squared is equal to 0. Okay, so from this find out the k value. What is the k here? 0.707. This is the answer for this problem. So the range k range for this problem 0.70 to 0.72. Okay, so this is the range gain value for this problem. Okay, for further related videos you can like, share and subscribe my channel. Thank you.